My name is Caroline de Vever. I'm head of the communication cell here at the Royal Belgian Institute for Space Aeronomy, and my favorite planet is Mars. Many people, including scientists, actually think about the moon as a grey rock there in the sky above us, but actually it's more scientifically interesting than you may think. The good thing about the moon is that it can be considered as a kind of step in between to go to deeper space. Because it takes only 3 days to go to the moon, while going to Mars you need 6 to 7 months. So actually the moon, due to its proximity, or thanks to its proximity, it's actually an ideal test bed for all kinds of technologies to test this close by before actually going to further on to Mars. Dust is actually one of the major challenges that astronauts will have to deal with once they are on the moon. It's something very static and very dangerous. It impacts the astronauts' health, for instance, because it can penetrate in the breathing airways or the lungs of astronauts. But it can also have an impact on the technology, sometimes on instruments that are important for the life also of astronauts. You can imagine some oxygen tank or things like this. When it gets obstructed by the dust, it can have nefast consequences. Something dust on the Earth and the Moon have in common is that it's something really annoying. We rather want to get rid of it than have it there. And I would say that on Earth that's quite easy to do. You just use a vacuum cleaner or some dust cloth or something to move it, or you just even rub it off with your hands. But on the Moon it's not so easy to do so, because the dust on the Moon is electrically charged. So that makes that it clings to everything. You have the Moon here, illuminated by the solar radiation, and this tends to extract electrons from the surface. So the surface is left with a positive charging of about 10 volts. On the other side of the Moon, the surface tends to be left with a negative charging between -100 and -200 volts, more or less. Because of this fast transition between the negatively charged side and the positively charged side, electrons tend to be levitated and move from the negatively charged to the positively charged side. So this mechanism could be the cause of the levitation of the dust and the transportation over very long distances that can be seen around this terminator, so this transition region. So with the DUSTER project, we actually aim at studying the properties of dust. We use lunar dust simulants, so it's actually an imitation of how lunar dust would look like. So the idea is to develop an instrument that can actually do this on the lunar surface itself. So during one of the next space missions, when we put a lunar robotic lander on the surface, we would like to have an instrument on board that can actually measure the electric charging of the dust very locally and see how we can move the particles. So how we can remove them from some surfaces, but also maybe to use it for dust collection.